Good morning, grade 11s, and welcome to this morning's mathematics webinar. I am just going to allow for a minute or two for some attendees to still come on board. I see that they're still coming in, so let's just give them a minute or two to just join us this morning. I'll be with you shortly. Right, I think that everything is stabilized and I don't see a lot of people still coming on. So I am going to start with this morning's webinar. Firstly, I would like to say welcome to today. Hopefully you joined me 2 weeks back again or also, and if you didn't, welcome to your first Impact webinar where we will discuss mathematics. Please make sure that you are a mathematics student and not a mathematical literacy student. Mathematical literacy will be presented to you next week. All right. Then let's start with some basics before we start with the content. So if you're struggling to hear me, please make sure that your audio is on and that your speaker volume is turned up. I am just going to highlight that for the guys because it doesn't help. I'm telling them that and they can't hear me to make them see that. Right. So let me just see. Can everyone hear me? There's a little hand that you can put up on your dashboard. So just put up your hand. Thank you. Thanks. I see that there's a lot of you putting up your hands and that you can hear me clearly. Okay, great. So I assume that you have used this tool before and it is quite easy to use if you haven't before. All right, so I'm just going to take down your hands for now. I am going to use the hand for some interaction between me and you, as well as when you want to ask a question. All right, so I'm just going to take down the hands for now. Right, you will automatically be muted when you join this session. So during the session, I am allowing some time for answers. That is when I'm going to ask you, please put up your hand and then I will get to your answer. I will unmute you. You can ask your question and afterwards I'll mute you again. Right, should you have any questions, you can ask your question in the question box below on your right. That's on your dashboard. You will see that there's a question box. So you're welcome to type your questions over there. I am also going to allow you to ask your question verbally. It goes a bit quicker as well. So you're welcome to use that option as well. Right, to raise your hand, you can click on the hand icon on your dashboard. If you didn't use it now, when I ask you to just show me that you can hear me, you're welcome to quickly test that out. So you can press on your hand, make sure that you put up your hand, know where the button is. I am going to use that for interaction during the session. Right. You can also download this presentation and any additional resources in your handout box. Your handout box is also on your dashboard. For the purpose of this webinar, this presentation in PDF format will be available for you to download. Now, you can download that now. You can download it during the session, but after the broadcast ended, you won't be able to download it anymore. So remember to do that if you would like that. Right, you will find all of this information in the question box below or on your right-hand side, that is on your dashboard. Remember to ask all your questions or send us all your questions. We do encourage our attendees to ask questions and leave comments. However, should you leave irrelevant or inappropriate comments, you will be dismissed from the session. If we do not get to your question, you're welcome to ask your content and your academics questions by sending an email to academics@impact.co.za. The question in the question box will be answered and made available afterwards. If you did not receive the question and answers, please send an email to info@impact.co.za. You're also welcome to, and we actually invite you to visit our YouTube channel. I am going to share that URL for you at the end of the session. So go and have a look over there. All our recordings of the webinars that is presented will be uploaded there for you to go and have a look at. I also just want to say that we had a lot of requests for Afrikaans sessions that came in as well. So if you are an Afrikaans student that's tuning in this morning, you're welcome to attend the Afrikaans session of this on Friday afternoon, or you're also welcome to stay and listen to the English one. Up to you. Right, so let's start with this session. Let me just take away all of this. There we go. Right. So up until now, we've looked intensively at trigonometry, and I just quickly want to review all the topics that you need to do for term 2, which will include trigonometry. Right, so for term 2, you need to do trigonometry, functions, analytical geometry, and number patterns. So up until now, your notes that was sent out last week and the previous webinar was about trigonometry. Now, the notes is available on the guided learning platform under resources. Please kind of have a look over there. It's quite extensive. It explains a lot. It gives you links to videos and explanations and some practice. So go and have a look over there. It builds on our previous webinar, and you need that information to be able to do this webinar or follow this webinar as well. So if you haven't, please go and download and have a look at that notes that is made available to you. If you are an external learner that is not registered with Impact, you're welcome to send an email to info@impact.co.za and request the notes that they can send it to you. Right. So like I said, we've spent a lot of time on trigonometry, and today we are still going to spend some time on trigonometry. This will be the last part of trigonometry that we will do before we move on to functions. So functions will be part of the notes that will be sent out next week. Right, so this is all the topics that you need to do for trigonometry in grade 11. So you will revise your trigonometry of grade 10. We've done that in the previous webinar, fundamental identities and simplifying trigonometric expressions, then deriving reductions formula, proving trigonometric expressions, solving trigonometric equations, and lastly, sine, cosine, and your area rules. This sine, cosine, and area rules are what we are going to do today. So what makes it so special is that, yes, we are still going to work with triangles, but in this case, we're going to work with triangles that is not right-angled triangles, meaning it does not have a 90-degree angle over there. So we do get angles that have acute angles, meaning they are smaller than 90 degrees, or a triangle with an obtuse angle, meaning the angle over there is more than 90 degrees. Right, I am going to make some time for questions while we are doing the 3 rules. So hold your question, and when I ask you, you can put up your hand to ask your question over there. Right, sin, cos, and area rule. Like I said, we are not going to work in right-angled triangles. We're going to use obtuse triangles and acute triangles. So let's start with the area rule. What does the word area mean? it means that I need to find the size that it covers, the base that it covers. So we did use a specific equation to find the area of a triangle. And I'm sure that most of you know that the area of a triangle is half base times perpendicular height. But there I made mention of perpendicular height. Perpendicular means 90 degree. And I said we're not going to work with 90-degree triangles. So what now? Right, so again, this is the equation that you will use with a right angle triangle, meaning I have a 90-degree angle over there. So my base will be here at the bottom, and the height, of course, will be that part over there. But now I have an angle that does not have a 90-degree angle. Before we can move on, there's something that you need to know and how you are going to name all of your triangles with all three of these rules that we're going to do. So I'm going to start with a simple A, B, and C triangle over here. So the angles, the vertices of this triangle, I'm going to name capital letters A, B, and C. Now, with all of these rules, so the Sine rule, the Cos rule, and the area rule, you are going to use sides as well. And we need to name that sides in reference to the angles in the triangle. So you will see here a small letter A, and that is the side right opposite to the angle A. Side B is the opposite side to the angle B over here. And side C is the opposite side to the angle C over there. So you will see the angles we name in capital letters and the sides in small letters over there. Right. So for the purpose of showing you how they got to the area rule, I'm just going to draw a perpendicular line down, which will be the perpendicular height that you are used to, and I'm going to call it H for the height. All right. So if I look at this triangle and I apply this equation that you know, the area is half base times perpendicular height. If I apply to this triangle here, I will say half base, and I know that my base is this side over here, which is my small letter C, so half C times my perpendicular height in this case is the H over there. Right. I am going to add another label over there, which is N. It is where this perpendicular height ends on my base side C over there. Right. Why do I want to use this now? You will see that it makes a 90-degree triangle over here that I am used to working with. Right. So in triangle IACN, I know that the sin of A, so meaning I need to stand at A, is opposite over hypotenuse. So it is my H over B. I am just going to move this around, taking the B to this side. It means that I have my H over here. But look here, I have an H over there as well. I can actually substitute this H into that space over there. So I'm going to substitute my H in there. H is equal to B sin A, which you can find over there. Right. You have now the formula and the equation that you're going to use to find the area of a non-right angled triangle. You're going to have half BC sin A. Now let me just show you how it works. So I'll have the half, BC are two sides, and sin A. The angle that they talk about is the included angle. Do you see? It's enclosed. It is between two sides, the two sides that I am referring to. Now, of course, I can move it to half BA sin C or half AC sin B. and still make use of this equation. So this equation is what you need to know. What we've done over here is just to show you how did we get to this formula over there. So what does the area rule say? It says that the area of any triangle, do you see it's not only a right-angled triangle. The area of any triangle is equal to half of the product of the two lengths of the two sides of the triangle multiplied by the sine of the included angle. So we looked at that already. It is half the product. Product means multiply. So half the product of two sides of the triangle multiplied by the sine of the included angle. So if I talk about B and C as my two sides, my included angle is A. So what about if I used A and B or BA? It doesn't matter. Remember the commutative law of multiplication. My included angle will be C, so my C need to change over there. Right, and we said AC and sin B will be exactly the same. Right, so how are we going to use that? Now, this is the formula that I'm going to put up there that you can use as reference. Unfortunately, in grade 10 and 11, you know by now that you will not receive a formula sheet. So you need to remember that. You will receive a formula sheet in grade 12, but not in grade 11. Okay, so make sure that you know your formulas off by heart. Right. So they ask a very simple question over here. Calculate the area of triangle A, B, and C. So wonderful. I see that I have two sides over there and I have an included angle. But for the purpose of showing you how I'm going to substitute it into this equation is I'm just going to name my sides quickly. So my angles are named labeled very clearly over here. I just want to label my sides as well. Okay, so we said we do have our two sides and an included angle over here. So the side opposite my angle A is small letter A. The side opposite my angle B is small letter B. And the side opposite my angle C is small letter C. So if I look over here, A and C is my two sides. And my included angle is B. So if I use this formula that is given to me, I am going to change it up a little bit. I will say half AC sin B. So it's half of the product of my two sides multiplied by the sin of my included angle over here. So I'm just going to substitute it in there. Half A is 7, C is 10, sin B, which is sin 45 degrees. And you put that into your calculator. You'll say half times 7 times 10 times sin 54 degrees, and you will get an answer of 28,32 units squared. So I say units squared because I'm working with an area, and any area is centimeter squared, meter squared, kilometer squared, any unit squared. So in this case, they didn't say that the size is 7 centimeters or 7 millimeters. That is why I just say units squared. So with area, remember that your unit should be indicated, which is your unit, the given unit squared, or if they don't give you the unit, you can just say units squared. Right. So let's look at this example over here. So now they say calculate the area of triangle AOB. They say that the radius of the circle is 6 centimeters, and they say that AOB, meaning the angle O, is equal to 130 degrees. All right. What do I really have? They say that the radius of the circle, so they should have said that the midpoint of the circle is O. but the radius of the circle, so it's the length from the midpoint to the circumference of the circle, that length is my radius, and they say that the radius is 6 centimeters. But if you look at this line over here, it's also from the midpoint to the circumference of the circle. Therefore, this is also the radius, and I know that it is also 6. I also know then I have 2 sides over there. They give me they give angle O, which is 130 degrees, and I've just substituted or shown it on the diagram for yourself. So I do have 2 sides over here with an included angle. Right, so where do I start? I start with naming my sides again. So the side opposite A, angle A, will be small letter A. The side opposite angle B will be small letter b, and the side opposite angle O will be small letter O over there. So I'm going to use this information and substitute it into the equation for the area of a circle. So the area is half AB, because that's my 2 known sides, sin my included angle, which is O, and 130 degrees. So I'm going to substitute it in there, half times 6, because A is 6, B is 6, and my angle O is 130 degrees. So when I substitute it in there, I will get an area of 13,79 centimeter squared at this stage, because they gave me a unit of centimeters over there. Right. Is there any questions regarding the area rule? You're welcome to put up your hand. We'll unmute you and you can ask your question. Right, Tanisha? Tanisha, you can ask your question. Yes.
Sorry, no, my hand was raised accidentally. I'm sorry.
It's fine. Do you understand everything? You're fine?
Yes, I do. Thank you, ma'am.
Okay, great. Right, Jacobus Potgieter.
Hello, ma'am. Just asking, out of all the trinomials, is the circle one the difficult?
Out of all the trigonometry questions.
Yeah, is the circle the most difficult?
I wouldn't say it's the most difficult. It's just that you will feel that they are missing some information because they will only give you one side. And you need to realize that the radius actually gives you all sides that starts from the center of the circle.
Okay, thank you, ma'am.
Pleasure. Right. Good so. Good so, you are self-muted. So if you want to ask a question, just unmute yourself and then you can ask your question.
Hi, ma'am.
Hi.
There's one question that I want to ask about the circumference of the circle. Does it apply to every circle that all sides will be a certain number? When, this example, it's with the one that we did previously, it was a 6. And maybe if you put an 8 there with a different circle, would it be the same thing?
Okay, so if that 6 was substituted with an 8, the radius would have been 8. And the radius, the definition of the radius is the length from the center of the circle to the circumference of the circle. So any place in the circle from the center to the circumference will be the same length. So if they're given that length to you as 8 or 100 or 5,000, you know that the length of any of those sides of a triangle from the center of the circle to the circumference of the circle will be the same length, the radius.
Okay.
Okay. Right. It seems that Neo, if you have a question, you can ask your question regarding the area rule. You are self-muted, so just put on your microphone if you want to ask a question.
Hello, ma'am.
Hi.
I wanted to ask, if we don't have the radiant, how do we calculate it if we're not given it?
Then the question will be structured differently, and you probably will use Pythagoras, so they will give you a 90-degree triangle or something like that.
Okay.
But this was just to show that if they give you one radius, it means that any other side that actually conforms to the rule of a radius, you can actually give that line as well, the same length. In this case, they would give you other information in that if they left out that specific part.
Okay, thank you.
Okay. Pleasure. Right, it seems that everyone is on the same page. I'm going to take down all the hands and then continue. Right, so the area rule was specifically to find the area of a triangle. Now, the two other rules, sin and cos, is actually used to calculate sides and angles that we don't know. So I'm going to start with the sin rule over here. So the sin rule is used to find the unknown sides and angles in non-right angled triangles. Remember, we said we're working in non-right angled triangles at the moment. So I'm just going to use this triangle that we have named and labeled in our area rule. So the same will happen over here. I have my three angles, which is A, B, C, and just name their opposite sides. Small letter A, small letter B, and small letter C over here. I've kept this just to show you. I'm going to use this again, just to show you how we get to the sin rule before we actually start to use it. Right. So if I look at triangle ACN, I know that sin A is my opposite, which is A, over my hypotenuse, which is B. So we've done that, and you should know that with regards to your trigonometric ratios. And just to get my h alone, I multiplied my b on that side, so h is equal to b sin a. So if I work in triangle BCN, I'm standing at angle B here. Sin is opposite over hypotenuse, which in this case is h over a. Again, I'm just going to make my h my subject over here. So I'll have h is equal to a sin b. So if I multiply my a on that side. So h and h is the same, right? So it means that the right-hand side should be equal to this right-hand side over there. So I take this, b sin a is equal to a sin b. Now it's just swapping around. I'm going to divide with my b on this side, divide with my b on that side. The two b's here will cancel, and I'll have a sin b over b, and the same with the a. It comes down to sin a over a is equal to sin b over b. And we can work that out with another right-angled or perpendicular line over here, but it can be extended to sin c over c. Right, so it's quite easy to remember. Sin of the angle A over the side A is equal to sin of the angle B over the side B is equal to sin of the angle C over the side C. Right, so this is the formula that you're going to use to find unknown sides and angles in non-right angled triangles. Right, when can I use and when do I use my sin rule? So we said when I have unknown sides and angles, but it's very broad. You know, when should I use? When should I use the sin rule? When should I use the cos rule? So in this case, let's just check. So when you have two angles and a side given, you can calculate the second side. Now, it's very important here that you know it is the two angles. So let's say A and C. So it must be this corresponding side, which is C, and the corresponding side A, what we are talking about. So if one of them are missing, or two sides and a non-included angle. So remember, with the area rule, we talked about an included or an enclosed angle. So it's between the two given sides, that angle over there. In this case, they say it should be two sides and a non-included angle given. It means that you will find the second angle. So these are the two conditions where you can use your Sine rule. All right. So let's go and see how we are going to use it and how it can be asked. So they say, in triangle ABC, find the size of angles A and angle C. Right, we said we want two sides and a non-included angle. So luckily, angle B is not included. Do you see I don't have the other side over here? So I have a side over here, a side over there, and an angle which is not included. Right. There I've just named all the sides. So opposite angle A, side A, opposite angle C, side C, and opposite angle B is side B over there. I've added the equation just there at the top for you for reference, as this is probably the first time that you've heard or seen it. So you are going to use this equation over here or parts of this equation to actually solve this question. Right. So let's look at angle A over here. I want to find this first. So sin A is equal to A. Yes, sin A over the side A, I have that. And I have sin B, I have this angle, and I have that side. So great, I know that this rule will work. I'm going to use sin A over A is equal to sin B over B. So I'm going to substitute in here what I have. So sin A, I don't have the angle yet. That's what I want to calculate over my side A, which is 8. Sin B, which is sin 62 degrees, over my side B, which is 11 in this case. So I am going to multiply my 8 on this side because I want my sin A alone, because in the end I want to calculate my angle A. So this expression over here, I'm just going to put into the calculator and you will find a decimal. Right. So if you think back to grade 10, when we wanted to calculate an angle, we said sin to the power of -1 with this value over here will give me the angle, and you're going to do that on your calculator. So this is the way you write it. On your calculator, if you have a Casio, you will press Shift Sin. You will see that it gives you that to the power of -1. So Shift Sin and the value here, 0.62143. We don't like to round off in a question. We will round off at the end. If you don't have a Casio and you have a sharp, you will see that you don't have a shift, but you have a second function button on your left-hand side, top left-hand side. So you can press second function sin, this value, and equal. It means that your angle will be given as 39.95 degrees. So this is a rounded off answer over here to two decimal places. Right, so I've calculated angle A, which is what I wanted. They say find the sizes of angle A and angle C. Now, if you look at angle C, it's very difficult to see that I'm going to use this because I need side C to actually find angle C, and I don't have side C. And I cannot use Pythagoras to find this side over here as well. But I do have two angles. I need a third one. And now you need to think of Euclidean geometry over here. What do you know about the interior angles of a triangle? And you know that the interior angles of a triangle is equal to 180 degrees, right? So you will say 180 degrees minus my angle B, which is 62 degrees, minus my angle A, which is 39.95. And that means that your angle C will be 78.05 degrees. Sorry, there should be a degree sign over there. Okay. Why did I show you this? It means to show you that even though we would like to box in mathematics, that you only do algebra and algebra, that you only do trig and trig, it does not always happen that way. Algebra can be found anywhere in your mathematics. And you even get to places where it's unexpected, where you need to actually apply Euclidean geometry. It won't be integrate, it won't be difficult, but it's simple things that you need to remember that you can still use in specific places in your work, which you can apply it to. Okay, so the Sine rule is quite straightforward. There's no tricky stuff over there, but I am going to allow some questions. So if you do have a question regarding the Sine rule, you're welcome to quickly put up your hand and I will give you some time to answer to ask your question. Right, so Denisha, you can ask your question. Denisha? Okay, we can't hear her at the moment. I'm going to move on. Ernest, you're self-muted, so you can just put on your microphone. You can ask your question. Okay, it seems like Ernest doesn't want to ask a question or is struggling. Right, Prasad, is it Prasad?
Oh, hi. I'm just a bit worried about the what's it, the how we apply the rules and everything. I'm just like, how do you apply the knowledge in all the triangles? Because you can get 3-star and 4-star questions in your book.
Yes. So it depends on what information is given to you. That is why each time I tell you when you can use this rule. So it's easy with the area rule. You will only use the area rule when they ask you the area of the triangle. So your decision should just be between the Cos rule and the Sine rule. And the cos and the sine rule you'll only use when you have non-right angle triangles. In your right angle triangles, you're going to use your trigonometric ratios, so opposite, over, adjacent, all those things that you've used, and Pythagoras. But in non-right angle triangles, you're going to use your sine and your cos rule. So with the sine rule, you will check out the information given. So if they've given you 2 sides or 2 angles, and let's start with 2 sides and a non-included angle, you know that you can use your sine rule. And if they give you 2 sides and an angle and you need to calculate, sorry, I just said that now. So if they give you 2 angles and another side, you can use that to calculate your second side. So when we get to the Cos rule, you will see that there are other requirements that you need to look at. So what kind of sides is given and what kind of angles is given. So in the process of deciding which rule to use, you're going to use it what is given to you and the type of triangle that is given to you. So if it is non-right angled, you're going to have to make your decision between sine and cos. And that decision will depend on the information given in the question itself. like I said, the area rule will only be used when they ask you to calculate the area of a non-right angled triangle.
But I just want to also ask, but in the test or exam, they will ask, in a sine, when you have to use sine, will they give you two sides, or they give you all the information in the test, and the exam they will not give you not information?
Yes, they will give you enough information to make your decision, or they can even give you more information that you can make any decision between sine and cos. It means that you can use any one of the two. So like I said, it all depends on what they give you in the question. So they will give you enough information to make a decision, or they will give you an abundance of information, and then the choice is up to you. You can use either one of the two rules.
But it's usually two values.
Sorry?
It's always two values they will give you.
In this case, there should be three values. So two sides and a non-included angle should be given.
Oh, okay. All right. Thank you.
Okay, pleasure. Right, Neo, do you have a question? You are self-muted, so just put on your microphone and then you can ask your question.
Ma'am, like when we ask to find the size of the angles, do we always have to use the sine rule?
No, you will see that you can also use the Cos rule that we are going to do now.
Okay.
Sine rule is the easiest one between the two.
Okay. Thank you.
You can use the sin rule, use the sin rule.
Okay, ma'am.
Okay. That is in non-right angle triangles, right? In a right angle triangle, you can make use of your normal trigonometric expressions to find that angle.
Okay, ma'am. Thank you.
Okay, pleasure. Bye-bye.
Bye.
Just want to mute her again. There we go. Just check the time. Okay. I am going to move on, so I'm going to take down the hands. Otherwise, we are going to run out of time. I quickly want to look at the Cos rule over here, and then I'm going to allow some more questions if we have time in the end. So we are going to use this Cos rule to find the third side when two sides and an included angle are given. So yes, we talked about given two sides and an included angle, but that was with area rule. And like I mentioned, you're only going to use your area rule when they ask you to calculate the area of a triangle. So here it's different. They will ask you to find the third side, and you cannot make use of Pythagoras because you don't have a right angled triangle. You have an acute or an obtuse triangle over here. Right, so you're going to use it when you have two sides and an included angle given. So again, you're going to look at the information that is given to you in your question. Do I have an included angle with two sides, or do I have a non-included angle and two sides? Right, so what makes it different than the sin rule is that I'm working with an included angle over here. Right, so this is what the Cos rule looks like. I'm just going to talk through it with you. So the small letter a squared that you're going to calculate over here, do you see its opposite angle A? And that is where that angle A comes from there with your cos A. So how do I get this side over here? It's the sum of the squares of the two other sides. So if I want side A, I will say b squared plus c squared minus 2bc, so it's still that two other sides, cos, and the opposite angle over there. So there's the side, there's the angle. It can also be moved around. So if I'm looking for side B, I will work with cos B. Okay? Cos B, not will cos B, but cos angle B. Right. So it's a squared plus c squared minus 2ac cos b. And of course, the same will apply to side c squared is a squared plus b squared minus 2ab cos C over there. Right. You can go and have a look at the proof. So with the rest, I've shown you where did they get to this formula or this equation that you're going to use. But we don't have the time to go through that for the Cos Rule as well. You're welcome to go and have a look at the proof of the Cos Rule at the link that I've given there for you. Right, so remember that you can download the sites in PDF in the handout box. Right, so let's apply it. They say they want us to find P in angle PQR. So if I look over here, I have two sides and then included angle. So it will be, let us just name the different sides, and that is the equation that you're going to use. So if I apply this equation to this specific triangle, I will get P squared is equal to Q squared plus R squared minus 2QR cos P. Substituting everything that I have in here on the triangle, so Q is 9, R is 8, Q and R again, and cos of 120 degree. You put that into your calculator. Now remember, this is for P squared. So the answer that I've gotten here is for P squared. And then I need to get the square root of my answer to get the value for P, which is 14.73. And it is a length over there. So it's actually a unit that you are calculating. So all of this rule, so your area, your sin, and your cos rule is actually just a substitution of the information that you already have into an equation. So the equation actually does all the thinking for you. So you just need to solve the unknown in every calculation that you do. Right, you can also use this to calculate an included angle. So this is when you have all three sides. So you have P, you have Q, and you have R, and you can calculate this thing, right? Okay, so this was a very quick look over the Cos Rule. Like I said, it's just applying and substituting information into a formula. The difference between the cos and the sin rule is that sin is when you have two given sides with a not included angle over there. The cos rule is when you have two sides and an included angle. So like I said, it depends on the information that is given in the question. Area rule is also two sides with an included angle, but you only use it when they ask you to find the area of the triangle, and the triangle is not a right-angled triangle. Right. Yeah, I've given you 3 links to where you can do some extra practice. Some of them are actually online practice that you can do. Others are pieces out of electronic textbooks that is available on the internet. So if you want to go and practice, look at those websites, go and practice it, see how they got to the answers, and actually work in your skills over there. Secondly, you can look at our own YouTube videos that is made available regarding the sin, cos, and area rule. Someone is actually explaining the work as well. There is some examples done in there, and you can actually practice that as well. Then I've also provided the link to our YouTube channel. So all of the webinars that was presented already is uploaded over there. This one will also be uploaded onto that YouTube channel. And remember that you can actually also download the PDF format of this in your handout box. So if you want to do that, you need to do that before we end the broadcast of this webinar. Right, so we don't have a lot of time for questions, but we have about 10 minutes. So I'm just going to see if you have any question, you can put up your hand. I will unmute you. You can ask your question, and then I'll mute you afterwards again. Right, Denisha, Do you have a question? I see your hand is still up.
Ma'am, according to my laptop, it doesn't indicate that my hand is raised.
Is it? Okay, sorry, but it's on my side.
It's
It's
okay.
fine. If you don't have a question, I'm gonna move on. Right, Prasad, I see that you still have a question, or is it your previous hand that is still up?
Do you know? Do we know when we start exams? When will the exams start?
So even, you know, the whole education sector out there is very unsure of what is going to happen and what the minister actually has to say regarding our education of this coming year. As soon as we get any more information, we will definitely communicate it to you guys as soon as we know. For now, you don't have to worry. We won't start the June exam if the schools aren't even open yet. But we are carrying on with work because we don't want to fall behind.
Oh, okay.
Okay. Right. Is it Vutali? Vutali, do you have a question? Okay, hand is going down. Right. Anya Smith.
Hi. I just wanted to know, why don't we have the formula sheet for grade 11?
Okay, so it is prescribed by the curriculum, so the CAPS document, that grade 10 and 11s do not get formula sheets. I am not sure why the decision was made, but unfortunately we are prescribed not to provide you with formula sheets.
Oh, okay, thank you.
It's a pleasure. Let me just see, did I see Hendrey van der Walt? Hendrey?
Hi there.
Hi.
Hi. I just want to make sure when we write our tests, do we just mark it ourselves, or do we need to send it to you via email or something?
Okay, so your tests is still marked by your facilitator. Your
Okay.
examinations will be marked by Impact. So I'm not sure about your June. I think your June and your November examinations will be marked by Impact, and you will actually be able to upload your examination onto the platform where the markers will then find it and mark it over there. But all of that information will be sent out prior to the time that you need to upload by the assessment department. But should you have any questions regarding that, you're welcome to send an email to assessment@impact.co.za.
Okay, thank you very much.
Pleasure. Lehanza Fluer. Hi.
The tests that we have to write next week, will that also be cancelled, or are we still writing them?
So I don't have a straightforward answer for you regarding that. Should you be ready and you've covered your work, you're welcome to write the test so long. If you are unsure if you still need to write it in that time, I also don't have a lot of information regarding that. You can just send an email to assessment@impact.co.za. But I assume that you will have more time to write it than only that prescribed time because of all the uncertainties going on.
Okay, thank you.
Pleasure. Right, Tracy Lee.
Hi, ma'am.
Hi.
I just wanted to find out, what did you mean by included and excluded angles?
Okay, so an included angle is actually an angle in between the two given sides. So if you look at that, the angle there between the two given sides is included. When we talk about an excluded angle is when you have a side, and it's not referring to the angle between them, but it's another angle on the outside of those two sides. So it is not, how can I say, bordered by two given sides.
Okay. Thank you, ma'am.
Does it make sense?
Yeah, it does.
Okay, great. All right, bye-bye. Right. It seems like our time is up as well. Thank you so much for joining me. We will have a look at the questions in the question box if there is some questions over there. And we will give you some feedback regarding that. Right, so if you are an external client and you want to know more about Impact, you're welcome to contact us at info@impact.co.za for some more information regarding that. Thank you so much for joining me. I will see you in 2 weeks' time again. Next week, keep an eye open. Go to guided learning. Under your resources tab, you will find the notes of last week over there. So work through that. And next week, the new notes will be uploaded onto that system as well. If you're an outside client and you would like access to that notes as well, just send an email to info@impact.co.za and they will be able to send through the notes to you. All right. Thank you so much. Be safe, be healthy, and I'll see you in 2 weeks' time. Bye-bye.